To determine how tempo will be handled across all programs, simultaneously press and hold presets and parameters for a few seconds to enter the tempo menu. Here we can find the crucial parameters for overall tempo control. When source is set to program, the internal tempo will be taken from whatever was saved when the program was created. The tempo can be set manually with the first quick knob or with the first foot switch in this menu. The LED will blink to the BPM. We can also use an aux switch mapped to global tap tempo or an aux switch mapped to the tap tempo performance parameters of P, A, or B. The main point is, when source is set to program, it is possible to have different tempos for every program on our playlist. When source is set to global, the tempo is the same for all programs and can be adjusted with the same knob and tap switches as already mentioned. As you go from program to program, the tempo stays the same regardless of the tempo setting when the original program was created. Keep this in mind when designing a custom playlist, as it may not be desirable to have all programs synced to the same tempo. After all, songs in a setlist typically do not have the same tempo. When source is set to MIDI clock, the tempo is taken from an external MIDI clock signal, with no onboard adjustment possible. Tempo will also not respond to a performance tap tempo switch or aux switches, only MIDI clock from an external device. To designate whether the H90 listens to the 5-pin MIDI DIN input or the USB input, go into the System menu, choose MIDI, and adjust the clock source on the second page. By default, the H90's tempo source is set to program. All time-based effects on the H90 can be synced to tap tempo. For a preset to follow tempo, we must make sure Tempo Sync is on. Go into the Parameters menu and choose the preset we want to adjust. Whenever a preset is tempo synced, there will be a metronome symbol next to the hot knob indicator. To toggle tempo sync on or off, simultaneously press presets and parameters once. When off, global, program, and MIDI clock tempos have no effect on the preset. We simply rely on the manual parameter settings. Time-based presets will reflect delay times in milliseconds and LFO rates in hertz. When tempo sync is on, delay times and rates will be reflected in subdivisions, and we can manually set the BPM in the tempo menu or use the tap tempo performance parameter of a tempo synced preset to set the beats per minute of the program. It's also possible to assign an aux switch to control tap tempo either globally or map it to the individual performance parameters in a program. As mentioned previously, when MIDI clock is the tempo source, any tempo synced presets will follow the MIDI BPM, nothing else. For example, let's say we're in perform mode. Even though the P foot switch may be mapped to tap tempo, any non-tempo synced presets will not be influenced by this BPM setting. Nonetheless, in perform mode, it is possible to control the delay times and rates of non-tempo synced presets by assigning them to the tap performance parameter. Although we can see delay times and rates change as we tap, the presets won't respond to the program's tap tempo BPM. When assigning the tap performance parameter to foot switches of non-tempo synced presets, it's important to know that if an algorithm features more than one delay, tapping will sync all delays to the same time. Something to note, it is possible to assign a program-level tempo sync, but it's just a shortcut to toggling the tempo sync on both presets on or off simultaneously. On the right side of the back panel, there are two EXP control inputs. We can connect expression pedals, auxiliary switches, and send control voltages from 0 to 5 volts. In the System menu, under I/O, the third page of settings allows us to designate what we have connected, either an expression pedal or an aux switch with up to 3 buttons. When using a control voltage, set the pedal 1 or pedal 2 input to EXP1 or 2, depending on where it's connected. When connecting aux switches to the first EXP input, set pedal 1 to switches 1 through 3. When connecting to the second EXP input, set pedal 2 to switches 4 through 6. It's always best practice to connect to an expression pedal or aux switch first before connecting to either input. This way the H90 can accurately sense the load. To calibrate an expression pedal on the H90, enter the System menu and choose I/O. On the third page of settings, we find Calibration. Setting it to On redirects to a page instructing us to move the pedal from heel to toe. When working with a control voltage, we can send the signal here as well. When working with expression pedals, the H90 will automatically calibrate the range of expression as we move the pedal back and forth. Once we see a 0 to 100 sweep range, we know things are working properly. If the sweep behaves erratically or goes up and back down again, check to make sure we're connecting to the H90 with the appropriate cable. Some expression pedals only work with a TS cable, others use a TRS cable. Also, watch out for any internal dip switches or extra potentiometers. Some expression pedals use them to reverse the direction of the sweep or adjust the pedal's response curve. Double check to make sure the expression pedal is not designed for a specific device rather than being universal. It's also important to note that H90's expression ports cannot be configured for both expression pedals and aux switches at the same time. So, if an expression pedal features a built-in switch of some kind, it may require us to connect to both ports of the H90 to take full advantage of that feature. Eventide recommends expression pedals with a 10 kΩ to 25 kΩ linear potentiometer. While higher ratings work, we may find that all the range is compressed at one end of the pedal travel. It's best to stick with this recommendation. Calibration mode can also show us which switch numbers correspond to the aux switches we press. Whenever pedal 1 is set to switches 1 through 3, or pedal 2 is set to switches 4 through 6, the calibration mode screen will show us 3 circles for each group. We can think of these as 1, 2, 3, and 4, 5, 6. As we press switches, the corresponding circles will light up. We can then use this information to program the correct switch numbers when mapping parameters or global controls to external switches. In general, for a 3-button aux switch, the switch wired to tip corresponds to switch 1 or switch 4. Ring corresponds to switch 2 or switch 5. And tip plus ring corresponds to switch 3 or switch 6. The H90 accepts momentary, normally open aux switches. The wiring diagram for a typical 3-button aux switch is as follows. So far, we've learned to extend the range of control on the H90 by mapping performance, program, and preset parameters to expression pedals and auxiliary switches. In addition, the H90 offers another method of advanced external control using MIDI. Basically, the H90 can be operated with an external MIDI controller or MIDI loop switcher. As long as the controller is sending messages on the same channel as we set on the H90, we can receive program change messages to go to a different program and controller change messages to do things like activate or bypass, change parameter settings, and set tap tempo via MIDI. In addition, it's also possible to configure the H90 to transmit its own MIDI messages to control other devices. To access the MIDI preferences, press and hold Programs and Routing until we enter the System menu. Navigate to the MIDI option and press Select to enter. On the first page of MIDI settings, we can set the channel on which the H90 will receive and transmit information. Receive Omni allows the H90 to receive messages across all 16 available MIDI channels, while only transmitting on the channel we just specified. By default, this is set to off. We can also indicate how the MIDI output jack on the left side of the pedal will work. When set to transmit, the H90 will generate and transmit program change, controller change, and MIDI clock information to devices connected to the DIN MIDI output port. MIDI messages present at the DIN MIDI input will not be passed through. So, this is the optimal setting if we want the H90 to function as a controller for other devices connected via MIDI. For example, say we have an H9 connected to the MIDI output of the H90. As long as the H9's receive channel is set to the same MIDI channel as the H90, or in Omni mode, it will respond to program search commands sent from H90's select or bank modes. Tap tempo from the H90 will also be sent as long as source in the tempo menu is set to either global or program. However, if source is set to MIDI clock, the H90 will only respond to MIDI clock from an external device and not transmit that tempo. When the output mode is set to through, the H90 will automatically send MIDI information it receives at the DIN MIDI input through to any downstream devices. This is the best setting for when the H90 is being controlled by another device like a MIDI switcher. On the through setting, it will simply respond to the commands sent on its channel. It will also respond to MIDI clock and pass it on as well. This mode, however, will not pass on MIDI present at the USB input. Also, it will not generate its own MIDI commands as it does in transmit mode. Finally, when output mode is set to off, no MIDI information will be sent from the output to downstream devices. On the second page of MIDI preferences, we can designate whether the H90 responds to MIDI clock from the 5-pin DIN input or the USB port. Remember, the H90 will not respond to MIDI clock unless source in the tempo menu is set to MIDI clock. While it's possible to control tempo via the USB port, it's important to know that if we wish to have MIDI clock passed on to downstream MIDI devices, the connections must be made using the DIN MIDI ports. The USB port does not pass on clocking information to the DIN MIDI output port. Only clock present at the DIN MIDI input can be passed on. Also, the H90's output mode should be set to through. Downstream devices should be set to receive MIDI clock. The H90 will respond to PC and CC messages received at the USB input, but only program change messages can be passed on to downstream devices connected to the H90's DIN MIDI out. For this to work, the H90's output mode should be set to transmit. Downstream devices must be set to the correct MIDI channel. It's important to note, however, that the H90 does not respond to program change number 0, so it will not transmit PC0 to downstream devices. A reminder once again, MIDI clock received via the USB input does not get passed down to downstream devices either. Only MIDI clock received at the DIN MIDI input can get passed on. The next setting is PC offset. To understand what this does, it's important to know the MIDI specification allows programmers to use values from 0 to 127. Traditionally, this means that sending a MIDI program change message of PC number 0 recalls program 1. PC number 1 recalls program 2, PC number 2 recalls program 3, and so on. As you can see, the numbers are offset by 1. On the other hand, the H90 only makes use of 1 through 127, so that program change numbers work without an offset. This means sending PC number 1 will recall program 1, sending PC number 2 recalls program 2, and so forth. When PC offset is set to 0, the H90 responds to program messages from 1 through 127. It will not respond to PC number 0. However, when PC offset is set to 1, it will increment the incoming MIDI program change number by 1, such that PC number 0 is interpreted as PC number 1, like the normal MIDI specification. Similarly, the PC offset affects the value the H90 transmits when controlling downstream devices. To demonstrate, I'll set PC offset back to 0 and set the output mode to transmit. With these settings, the H90 will automatically send program messages to downstream devices. Notice the program number on the H90 is off by 1. This is because the H9 uses the traditional MIDI spec starting at 0 through 127, where PC number 0 recalls preset 1 and PC number 1 recalls preset 2. Again, off by 1. But if I set PC offset to 1, the H90 adds 1 to the PC number as it transmits, making up for this offset. Just like global pedal control serves to map H90 functions to external auxiliary switches and expression pedals across all programs, we can use MIDI global control to assign controller change numbers to parameters for MIDI control across all programs as well. Just enter the System menu, scroll to MIDI, and scroll to the third page of controls. When working with MIDI controller messages, it's necessary to know that we must assign a number to a function, but also send a value along with it. In the MIDI world, it's typical for a value from 0 to 63 to equal an off state, and the value from 64 to 127 equals an on state. To keep things simple, we'll say a value of 0 is off, and the value of 127 is on. Depending on the parameter we're assigning, it's necessary to understand how sending a value of 0 or 127 will be interpreted. When assigning controller change numbers to commands like increment program, decrement program, or mode toggle, sending a value of 127 will execute the command. 0 will not. It's that straightforward. As we peruse the list of global assignments, we find some with 2 versions. For example, notice how Program Active Bypass has a version with an M next to it. So do hot switch commands. This M stands for momentary. For the purposes of this example, in the MIDI Global Control menu, I'll assign CC number 14 to P Active Bypass and CC number 15 to P Active Bypass momentary. Here's how the H90 reacts depending on the value we send along with a controller number. An active bypass parameter, such as P active bypass, will toggle between the active and bypass state of the program so long as it receives a MIDI CC value of 64 or greater. This means every time we send a controller change message from a MIDI device with a value of 127, this command will change the current active state to the opposite state. Sending a value of 0 will have no effect. When using a momentary version, as in P active bypass M, the bypass state will be triggered with a CC value of less than 64, and the active state will be triggered with a CC value of 64 or greater. This option is best for when we don't want to toggle between states, but we require specific control of on and off commands, as in one button for off, another button for on. As we can see, Functions with momentary commands do not toggle with consecutive presses. Only non-momentary versions with values greater than 64 do. These types of toggling and momentary options are available for things like programs, preset A, preset B, and all 3 hot switches. Although the H90 has 2 EXP inputs for expression pedals and aux switches, it is possible to control parameters using an expression pedal via MIDI. To do so, connect the compatible expression pedal to a MIDI controller using the appropriate cable. Make sure the port is configured for an expression pedal and not an aux switch of some sort. In the software of my Morningstar MC6 Pro, for example, I can configure this port to be a wide range of things. For now, I'll just choose expression, and I'll also make sure it's set up to send expression data with controller change information. Next, we can assign a CC number to the port and make sure we're transmitting on the same channel as the device we want to control. For example, I'll assign it to CC number 11 on MIDI channel 1. Finally, on the H90, we can now assign parameters to the controller change number we've chosen for MIDI expression. This can be done on a program or global basis. To assign specific preset parameters to a CC number, press Parameters, choose the category, for example, Preset A parameters, and hold down the Quick Knob button of the parameter we wish to map. The easiest way to map is to just use the learn function, so the pedal automatically detects the CC number of the pedal as we move it back and forth. We can set a custom expression range on the next page if we want. Repeat this process to map more parameters to the same MIDI expression pedal. On the other hand, for global assignments, I recommend always mapping parameters to hot knob P, and then mapping hot knob P to a CC number in the MIDI global control menu. In this example, we mapped MIDI expression to CC number 11. Using this strategy, since parameters in custom ranges are mapped to hot knob P for every program, we can then use the expression pedal transmitting through the MIDI controller on the same CC number to control hot knob P for all programs globally. We can use expression pedals and auxiliary switches connected to the EXP input of the H90 to control external devices using MIDI CC messages. If we enter the System menu and select MIDI, the third setting on the first page of controls is the output mode. Set this to transmit for the H90 to send messages to other devices. Navigate to the last page of settings where we can find the MIDI transmit menu. Here we can choose an expression device under parameter and map it to a controller change number. Anytime we use an expression pedal or switch that has been mapped, it will send a MIDI controller change number from the MIDI out to downstream devices on the same MIDI channel. I'll set this to CC number 11 and send on MIDI channel 1. On the downstream device, program expression to respond to the same CC number on the same MIDI channel. In this setup, for example, I've mapped my expression pedal to not only control the H90's hot knob P, but it is simultaneously sending a MIDI message to control the expression on my H9 as well. I've also mapped my 3-button aux switch to search for programs on my H90. We can program the H90 to send MIDI program changes to simultaneously search for presets on the H9. To achieve this, on the H90, go into the Global Pedal Control menu and assign switches to Increment and Load and Decrement and Load. Now, every time we press a switch, not only will the H90 change programs, but it will also transmit a program change message to downstream devices. Of course, the key is setting the H90's MIDI output to transmit. Now, let's say the expression input on the H9 was already taken. We can use the H90's transmit capability to control the H9 via MIDI. For this to work, we must erase the global pedal control, increment and decrement mappings. This way, they won't automatically send program change messages. Instead, we can use the MIDI transmit menu to assign CC numbers to each switch. On the downstream device, we can program the search commands to respond to the same CC numbers. In this case, the H90 won't respond to these search commands, but it will transmit these messages to downstream devices via MIDI. The main takeaway is the H90 can use expression pedals and aux switches connected to the EXP control inputs to generate and distribute MIDI CC information to other devices. The H90 features two global bypass modes, DSP and Relay. Whenever a program is bypassed, this mode will affect how the signal running through the H90 is treated. To verify the H90's bypass mode, press and hold Programs and Routing to enter the system menu. Using Select, choose Global. The third option on the first page is Bypass. When set to DSP, the H90 introduces buffers to inputs and outputs 1 and 2 to help improve the signal after long cable runs. DSP mode allows users to maintain instrument and line level operating levels for inputs and outputs even when the program is bypassed. This is crucial, especially when an impedance mismatch between the input of the H90 and the input of the device we're connecting to exists. For example, this is the best option when connecting a guitar to the H90 and then connecting the H90 to a line level input on an interface that doesn't have high impedance inputs. Most notably, in DSP mode, we'll be able to hear effect tails whenever we bypass a program that has the tails parameter set to on. DSP is the default setting. When the bypass mode is set to Relay, the H90 keeps the signal analog through the pedal when bypassing a program. This is known as true bypass. We can literally hear the relay switch making this hardwired connection when bypassing a program. One important thing to note: when using dual routing mode, the global bypass mode only affects inputs and outputs 1 and 2. Global bypass mode does not affect I/O 3 and 4, as these are always in DSP mode. The key thing to realize is, if we're after true bypass in dual mode, only inputs and outputs 1 and 2 offer that functionality. On the H90, it's possible to have things like our delay and reverb tails continue to trail out even after bypassing either preset or the entire program. But there are a few things to keep in mind. When working in insert routing mode, the global bypass mode must be set to DSP for tails to work on a program level. When the global bypass mode is set to Relay, programs cannot trail out because there is a hardwired connection from input to output, preventing any digital output signal. Every program, preset, and insert on the H90 has a tails parameter that allows effects to trail out when they are bypassed. To demonstrate, I'm using a modified version of the first program with the presets in parallel. We can program tails in the parameters editing mode, where we can select programs and presets using the LED buttons. Let's choose P to control the program. Use Select to navigate to the last page, where we can find the tails parameter. Set it to off using the quick knob. With the program active, if we play a chord, we can hear effect tails as expected. If at any point we bypass the program, the tails get chopped off. On the other hand, if we set tails to on and try the same thing, we can hear the reverb and delay trail off when the program is bypassed. It's it's important to keep in mind this only works on the program level if the global bypass mode is set to DSP. If I set the delay tails to off and the reverb tails to on, bypassing both will only keep the reverb tail going. Likewise, if I set delay tails to on and reverb tails to off, bypassing both will only keep the delay trails going this time. Note that bypassing the program is not the same as bypassing each preset individually. Bypassing the program will still keep trails going as long as its tails parameter is set to on. Conversely, if the program tails is set to off, but both presets are set to on, it's possible to bypass both presets of an active program and keep trails going. Why would this be handy? Recall that if the H90 is set to relay bypass, deactivating a program will cut tails off. Using the double preset bypass method will allow us to essentially bypass the program but keep the tails going while in relay bypass mode. This is possible since both presets are connected digitally. Obviously, I realize it's impractical to step on two switches at a time in a live scenario, but this becomes powerful when using MIDI, which allows us to program multiple commands with one switch. Another solution is to go into Global Pedal Control and map A active bypass and B active bypass to an aux switch for simultaneous control. Inserts on the H90 also have a tails parameter. Once we enter the routing mode and create an insert, use Select to navigate to the third page. With tails on, we can bypass inserts from within the H90 and still have effect tails. Say, for example, we are using an effect that does not provide effect tails when bypassed, like the Earthquaker Space Spiral. Bypassing the insert on H90 with tails on will provide the same result as if we had bypassed the external pedal and it could trail out. Note that for this to work, the outboard pedal must remain active. Something to note: input and outputs 3 and 4, where inserts live, do not provide relay bypass. They will always operate in DSP mode. So, once again, it does not matter what the global bypass mode is set to. H90 inserts will always trail out when bypassed as long as their tails parameter is set to on and the external effect remains on. Kill dry is a function that, when enabled, does not send dry signal to the outputs, only the effect. On H90, it's possible to apply a global kill dry. To do this, go into the System menu by pressing and holding Programs and Routing. With Select, choose Global and press to get inside. Kill Dry is the third option on the second page of parameters. With the quick knob, we can set it to on or off. Press Perform to exit. By default, all programs are set to follow the global kill dry mode, but we can change kill dry individually for every program and presets within a program. To do this, go into the Parameters Editing menu. Choose the program or preset with the P, A, or B LEDs. Using Select, navigate to the last page in each category where we can find the Kill Dry parameter. With the quick knob, we can set it to Global, Off, or On. When set to Global, it will follow the System menu setting. Otherwise, setting it to On or Off will override the global setting. Kill Dry is useful whenever there's a parallel signal path. For example, when using the H90 as an effects processor in the send and return of a live sound console, it's better to run it in Kill Dry mode so we are not mixing the dry signal processed through the H90 with the dry signal from the originating channel. This can cause unwanted comb filtering. Kill Dry eliminates this problem. Similarly, when connecting the H90 to an amp with a parallel effects loop, setting the H90 to Kill Dry eliminates any problems that may arise with comb filtering. Inevitably, running signal through any digital processor introduces enough latency that when mixed with a dry path causes phasing issues. Again, Kill Dry fixes this problem. Kill Dry is also useful to control signal running through a program. Say we are running two algorithms in parallel. If we bypass one without Kill Dry engaged, there's a perceived change in volume because we're mixing the dry signal of the bypassed path on top of the signal going through the other algorithm. Running the parallel presets in Kill Dry and using the program's mix parameter to control the amount of dry signal can make it easier to get a more consistent dry level between an active and a bypassed program. These are just a few of the scenarios where Kill Dry is useful. Spillover allows effects to continue trailing out even after we've switched programs. This is not meant to be confused with the tails parameter on programs and presets, which allow effect tails to continue going after they have been bypassed. Spillover time can be adjusted in the System menu on the Global category's second page. Time ranges from 0 seconds to 30 seconds. The factory default is 10 seconds, which generally works very well. So, why would we go shorter or longer? Longer times means we have to wait a longer spillover length to change to a third program. Consecutive program changes with too long of a spillover time can interrupt the tail of the second transition. If the spillover time is too short, then we run the risk of fading out a long reverb tail too soon. Understand that most of the time, we will continue playing once we've switched programs, so extremely long spillover times will be unnecessary given the spillover signal will already be well below the nominal volume level. Conversely, spillover time can be used as an effect. For example, we can engage the freeze function on a reverb or polyphony preset and have the spillover fade out rather than stay frozen once a new program is loaded. Spillover is a very powerful and useful feature to have for seamless transitions. In the global settings, we find an option for source type. By telling the H90 what instrument we have connected to the input, the pedal optimizes the algorithms to function in the range of the specified instrument. There are options for guitar, bass, lead, and sub. Guitar and bass are self-explanatory, but lead and sub refer to synthesizers. In general, filters and tone controls adjust depending on the register of the instrument. For bass and sub settings, pitch effects get optimized for lower frequency material. The same thing happens on the lead synth setting, meant for extended upper range signals. For example, this setting provides faster monophonic tracking up high. If we decide to put vocals, woodwinds, or brass through the H90, stick with the guitar setting, which works for most source material, including 2-track playback for DJing. Unless we're playing a down-tuned extended range guitar tuned below B1, guitar will work just fine. If you sing like Barry White, you might consider the bass setting. To engage the tuner on the H90, press and hold the middle and right foot switches until the tuner appears on the screen. Using the first quick knob, we can adjust the tuning frequency. With the third quick knob, we can have the H90 mute upon entering tuner mode, or hear the signal pass through as we tune. Choosing to have the effects active or not while we tune is a matter of preference. Regardless, the tuner uses a pre-programmed signal. As we play the instrument, the tuner will display the note along with a readout of how many cents we are off. A minus sign indicates we are flat. If we're off by too much, on the left part of the screen, we'll see arrows pointing to the right indicating we need to tune up. A plus sign indicates we are sharp, and we'll see arrows pointing to the left. Once we see a double zero, this indicates we are in tune. Press any foot switch to exit tuner mode. It's important to note that we can enter the tuner from any mode except perform mode, since the foot switches are used for performance parameters. It is possible to map an auxiliary switch to access the tuner so that it's a one-button process. Once we've connected an aux switch and configured the EXP input, go into the System menu, into the Global section, and navigate to the last page, where we find Global Pedal Control. Select Tuner in the Parameter category, and set your control source to the appropriate switch number. Now we can get into and out of tuner mode with one button. To adjust the brightness of the pedal's LEDs, press and hold Programs and Routing to enter the System menu. With Select, navigate to Preferences and press to enter. The first parameter is LED brightness, which can be set to one of four options: low, low-medium, medium-high, and high. Press Select to go back to the System menu, or press Perform to exit. On this page, we can also adjust the screensaver to help preserve the longevity of the screen. Options range from 30 minutes up to 8 hours. Whenever there's no front panel interaction or signal in the specified time, the screensaver will come on. If we run sound through the H90 or touch the front panel, it wakes up. The H90 ships with a 12-volt 1-amp power supply with a center positive 2.5mm connector. It also comes with British, Australian, European, and Asian compatible connectors. To power it using an aftermarket pedalboard power supply, we need to give the H90 adequate current. Our measurements indicate that it is possible to safely power the H90 by providing either 800 mA at 9 volts or 600 mA at 12 volts. Since very few power supply options on the market offer this amount of power on a single outlet, in most cases it will require combining 2 or more outlets to provide the necessary current. Consult the power supply's manual to know exactly what its current ratings are at each voltage setting. To combine the current of 2 outlets into one, we must use a current doubling cable. This allows us to simply add up the current from each outlet. Then, connect that to a polarity reversal cable. Though most pedals have power inputs that take center negative 2.1mm connectors, the H90 requires a center positive 2.5mm barrel connector. A good option is the Voodoo Lab current doubler adapter cable coupled with their 2.5mm reverse polarity cable. This combination works with all power supply models that use barrel connectors. If we use Eventide's Power Max, Power Mini, or CHOCS DC series power supplies, the H90 can be powered with one outlet at 12 volts using the green Flex 4 cable. Something to note, when the pedal is turned off, the H90 makes a direct connection from input to output by automatically closing internal relays. This allows sound to pass through input and outputs 1 and 2 only. Similarly, even if the pedal was operating in dual mode, only input and outputs 1 and 2 will pass audio through when power is off. The USB-C input can serve two purposes: to receive MIDI from a MIDI host device, or to connect to a desktop computer to use the H90 control application. There are several MIDI host-capable controllers on the market that have USB outputs, like the Morningstar MC6 Pro, which I've featured in this tutorial. The Disaster Area MIDI Baby series also works with the H90. For either option to work, we must be transmitting on the same MIDI channel as the H90. We can assign a MIDI channel in the System menu under the MIDI category. If these devices will be sending MIDI clock over USB, we can specify this on the second page. Be sure to enter the Tempo Edit menu and set source to MIDI clock. By far the most important function of the USB-C port is to connect the H90 to a PC or Mac to use the H90 control software. To download it for free, go to eventideaudio.com and log into your Eventide account or create a new one. Then, register the serial number of the pedal. Scroll down to the icon and serial number of your pedal and click Docs and Downloads. Find the download that corresponds to your computer and install the software. This application can be used to edit programs and presets, manage user lists, and update the software. Every aspect of the pedal can be adjusted from the application with bidirectional control, meaning adjustments made on the pedal will reflect on the software and vice versa. With more visual feedback, it makes programming things like expression ranges, hot switches, and hot knobs a breeze. Thanks for checking out part 2 of the H90 tutorial series. Be sure to check out part 3, where I discuss dual routing and creative connections.